So welcome to the lecture where I will discuss about probable uh, PMP, probable maximum precipitation, PMP. Now this is nothing but the probability of the maximum possible precipitation for a given catchment area which cannot be exceeded. That means it is a rainfall which doesn't have a exceedance probability. That means that rainfall cannot be overtaken by other rainfall. So if you find the probability of that rainfall, of course for a given duration and given catchment area, then you are calculating PMP. Now these are used for designing various hydraulic structures like reservoir, dams, channels, spillways, for rainfall disposal, discharge, runoff disposal, soil erosion design, and various other related activities. So, what is the formula of this rainfall? The formula of this rainfall is PMP, probable maximum precipitation. It is P mean plus K multiplied by sigma. P mean is the mean precipitation of all the rainfall data given to the problem. Okay. Generally, all this rainfall data is the 100 years peak rainfall data or 50 years peak rainfall data. So, among which you will try to find out the rainfall which is the maximum amount. Suppose you have a 100-year rainfall data. 100-year rainfall data means the yearly peak rainfall data. So 100 rainfall data is given to you, which are the peak rainfall for its corresponding years. Now, among this 100 rainfall, if you can find the rainfall with the highest magnitude, that is peak of the peak rainfall. Now, if you can find the probability of that rainfall, it is assumed that that peak rainfall cannot be overtaken by any other rainfall for that given catchment. Okay, because that is peak of the peak rainfall for the previous 100 years. So it is assumed that that rainfall cannot be overtaken by any other rainfall. Although there is always a chance that that rainfall can also be exceeded. But while designing a hydraulic structure or reservoir, dams, spillways, etc., we have to assume that this is the highest magnitude that this structure has to consider. Because as this is 100 years peak rainfall, peak of the 100 years peak rainfall, then it is assumed that with the next 100 years, this type of rainfall will not occur. But yes, there is always a probability that this rainfall can also be exceeded. But meanwhile, how to calculate the probable maximum precipitation? Now, you have to use the mean precipitation of all the 100 years. You have 100 years peak rainfall, right? Suppose P1 to P100. You have to find the mean of these rainfall. K is the frequency factor, which depends on the statistical distribution of all the 100 years peak rainfall. Okay, and also the number of years of record you have and return period of those rainfall. That means if you have 100-year rainfall, K will be different compared to the when you have 50 years rainfall or 30 years rainfall. That means if you have at the peak rainfall of last 100 years, suppose K, there is a certain value of K, but for 50 years rainfall, this K50 will change. That means K100 and K50 will never be equal. They will never be equal. Similarly, 30 years peak rainfall, that K will also not be equal to K100 or K50. So K varies with the number of years of record you have, the return period of all the rainfall you have, and also the statistical distribution of that series, time series, okay, etc. So, and sigma is the standard deviation of the rainfall records that you have. That means in this case we have 100 years rainfall. You have to find the standard deviation, you have to find the mean precipitation, and K will be given to you. That means the value of K will be given. So just put down the value of mean rainfall, K, and standard deviation to find the probable maximum precipitation. Okay, so let us give an example how to calculate probable maximum precipitation. Correct. So the problem states that suppose the last, let me use the white, last 10 years rainfall data is given. So it will be not 20, 22, 21, 20, 19, 18, 17, 16, 15, 4, and 30. So the peak rainfall of the last 10 years is given to you. So these are all arbitrary values. So 135, so 100, then suppose 105, then 250, then 200, then 190, then suppose 350. So all the peak rainfall of the last 10 years is given. Correct? All of them is expressed in the unit millimeter. So we know these are all these are peak rainfall. So now this is the peak rainfall. So you have been said the find the exceeded probability of the maximum precipitation, PMP. So the formula of PMP states P mean plus K frequency factor into sigma. So the first step will be to find the mean of all these rainfall, mean of peak rainfalls. Okay, all these 10 years rainfall is given, you have to calculate the mean of 10 years rainfall. If 20 years rainfall is given, then you have to calculate mean of 20 years rainfall. So let me see by using the calculator what is the mean of the rainfall. Correct? So first one is 135 plus, then 100 plus, 105 plus, 250 plus, this is suppose 200 plus, 190 plus, 350 plus, 300 plus, 250 plus, 150. So the total summation is 2030. There are 10 number of rainfalls, so divided by 10. So the mean is coming as 203. Correct? Now sigma. So how to find the standard deviation of all this rainfall? So sorry. So the mean rainfall is already calculated. So use the formula of standard deviation. So now for time constant, I will use an Excel formula to calculate Excel sheet for. So as the time is short, so I will use the Excel to calculate the standard deviation of all this rainfall. So let me see what are the rainfall. Yeah. So first one is 135, then 100, then 105, 105, then 250, 250, then let it be 260, 260, 190. So I'm basically writing the peak rainfall of the last 10 years. 190, 350, then 300, 250, 150. So 250, then you get 150. As you know, Excel has a very easy formula known as to calculate the standard deviation. STDV, just give STDV, then select the series. So it is coming 85.725. Correct? So 85.725. Suppose K is given as 0.15. Right? So K is 0.15. 0.15. Generally K is around 15, so it cannot be 0.15. So let us take K as 50. Okay. So the equation is becoming like this. So the equation is becoming like this. PMP is equals to 203, the mean, plus 15 multiplied by 85.725. Correct? 80. This is 85.725. Or rather, as there is 7566, so I will give it as 76. Because here you see it is 72566. So I will give it as 726. So let me calculate this also. So what I will do is I will multiply 15, which is the value of K, okay, with the standard deviation, and add the mean rainfall, which I have calculated to be 203. Okay, and then put enter. So the probable or maximum precipitation is coming here as probable maximum precipitation is coming here as what it is coming 1488.885. It is coming now as 1488.885. So that means I can say it as 1488.89. Right? 1488.885. So it's coming as 1488.89. Right? So it is very easy to perform this type of step. So when you are given the data of the previous year's rainfall, in this case I have given you 10 years rainfall data. I have given you the 10 years rainfall data. Correct. This is 10 years peak rainfall data. And then what you have to do is you have to calculate the mean of this rainfall data. This is arithmetic mean of the rainfall data, and standard deviation of that data. Okay, so and after calculating the standard deviation and mean of the rainfall data, You multiply k, that is the frequency factor, with the standard deviation of the data. In most of the cases, k will be equals to 15, although it depends upon the record of the number of rainfall you have, the distribution, statistical distribution of the rainfall data you have, and also the return periods of all the rainfall that you have. But however, it has been observed that k is for the maximum time, it is 50. So you multiply k with sigma, that is the standard deviation, and then add to the mean precipitation. That will give you the probable maximum precipitation, a precipitation which cannot be exceeded for that catchment at least. For that catchment, no precipitation can exceed this value. So if you can design a structure, spillway or likely dam or anything, for a precipitation of this value, then you can be rest assured that for the next 10 years at least, that or beyond that type of storm cannot damage that structure. So that is the advantage of calculating PMP, which is also known as probable maximum precipitation. Now, some other type of problems may also come. That type of problem states that they will, say for example, they will give you the mean rainfall, okay? They will give you the PMP also, and also the sigma. Mean rainfall given, PMP given, sigma given. We have to calculate K. Now, in a specific study, some scientists collected the greatest rainfall that has taken place in all over the world for a certain number of years, and they have put it in a log paper, graph paper, and has drawn a enveloping line, enveloping curve, which connects all those peak rainfalls that they have collected. So what they found is, they found a relationship between the mean rainfall and the duration of the rainfalls, and which states that mean rainfall is equals to 42.16 multiplied by duration of the rainfall to the power 0.475. So this is the relationship that exists between mean rainfall and duration of rainfall when the greatest rainfall of the world for the last 100 years is collected and arranged and plotted in a log graph paper, and then an enveloping curve was drawn which connects all those rainfall. Then if you find the equation of this curve, it is coming like this. So if this is your mean rainfall and this is your duration, the empirical equation is given by duration like this, which states that mean rainfall is equals to, so this mean rainfall is actually the mean of all the greatest rainfall that has taken place or occurred in the world. This is equals to 42.16 multiplied by the duration of those rainfall to the power 0.47. So this is for your information, although it is you can use it to estimate the mean rainfall or the PMP, probable maximum precipitation, by using this PM in this equation, K sigma. Okay, and then sigma can also be found from those rainfall data. K will be 15, assuming K is 15. The probable maximum precipitation that can happen in the entire world can be